Welcome everybody to typical C++, but why? Or as maybe typical C++, but why? You choose. I'm Björn Fahller, for those of you who don't know me. I live in Stockholm in Sweden. I work for NetInsight. We make networking equipment like these. This is a video switch used by broadcast media companies and other things like these. We connect them. We make everything from designing the mechanics to the network management systems and the networking stack and all the services and what have you. But let's not talk about that. Let's talk about jigsaw puzzles. So, I don't know, did you know that manufacturers of jigsaw puzzles use standard cutout patterns for their pieces? So that if you buy two jigsaw puzzles from the same manufacturer with the same physical dimensions and the same number of pieces, chances are that they match. That you can combine them like these. This artist, Tim Klein, he certainly knows that, as you can observe. This behavior of jigsaw puzzles reminds me of the C++ type system. Because, in a nutshell, the C++ type system has a small standard set of jigsaw puzzle piece shapes, which often fit in the wrong places. Yes, I'm specifically looking at the built-in integer types and floating point types, and some types actually in the standard library itself also. But C++ also allows you to create your own shapes and make them as generic or as specific as you want them to be. And this is a strength. And most developers, they create the special pieces that make up the big structure of the program. So here are the monsters, here are the pending requests, here are the network connections and what have you. But rarely for the information that is passed between these. That is at least my experience. And my intention today is to change that for you. Actually, I am quite subversively intending to make you go home and rewrite your code. Not all of it at once, please, but bit by bit. I'm going to do this by showing a bunch of examples of code. And I am sure that you will feel familiar with several of them. I will point out problems with them, and I will show examples of how to improve them. Also, it is worth mentioning that I know that occasionally I have done presentations about code that is fairly advanced. This is absolutely not it. If you're an absolute beginner of C++, you will be able to follow these examples. But I think that also experienced developers will learn something new. Many of them, at least. Maybe not all. All right, so without further ado, let's go into one of these examples. So we have some code that reacts to some kind of user input. So we want to read this input and do something with it. So we get some sanitized input because we know that we do not trust all the user types. That is useful. And then we query the user data. But you may perhaps see a bug here. So yeah, we get the input, we sanitize it, and we actually query it with the raw input that we didn't sanitize. You do not want your code to be a topic of an XKCD comic strip. You don't, really, you don't. But what to do? Because the author of this code knew about this problem. Why else would they have this sanitize input function? This was just an honest mistake. It was a bit stupid, but it happens. We make errors sometimes. And the really sad thing is, in this case, no compiler will warn for this at all, because the sanitized input is used. It's used in the log. If there wasn't a log there, some compilers would warn that sanitize has been given a value and then ignored. But no, it is used, so no warning. So that is not great. So what can we do? Well, we can change some signatures. You note at the top maybe now that sanitized input returns a sanitized string, and query user data takes a sanitized string. So how can we create a sanitized string type that prevents this error? Well, we can do this. Enormously advanced C++, you create a struct that holds a value. Which means that if you make this mistake, where you take a roasted string to query user data that expects a sanitized string, you get a compilation error. I don't know about you, but I prefer a compilation error to a few hours of debugging. And this is, yeah, well, it's C++, and compilation errors aren't always great, but they do actually tell what the problem is. But we can do a little bit better, maybe. So we can create a sanitized string class, and we have a conversion operator. Those of you who attended Chris's talk earlier today will know a little bit about this. So the way this works is, here as an example, I have a class C that has an operator int and a function work that takes an int. And when you call work with an instance of C, the compiler sees that C is not an int, but I know how to make an int of a C. I'm calling the conversion operator. And you almost always want your conversion operators to be const. Almost always. But since this is C++ and we have a long tradition of having the defaults wrong, we don't really want the conversion operator to be implicit. We want it to be used only when we explicitly say that we want the conversion. So here I'm using the explicit keyword to say that, no, you may not just on a whim become an int, but if I'm really asking for an int, here's the way to do it. So, and one way to do that is a static cast. Then you get the conversion operator called. Right? So that's why this explicit operator const string ref. And I use the value as private data here, and that is of value because once you have created a sanitized string instance, and you know it has a valid usable content, you don't want anyone to accidentally be able to modify it. So you keep it private, and you also have a constructor that takes a string, an explicit constructor again, because we don't just want to randomly have sanitized strings appearing. And this one can also throw if the string is too weird to be useful. And that makes it extremely difficult to have a sanitized string that is not safe to use in a query. So we can rewrite the code such that we get the sanitized input by creating a sanitized string from the input, and we're calling query user data with the sanitized input. And in my opinion, this code is clean. There are no ifs and buts. It's easy to read, and it's correct. And if you make a mistake, you will get a compilation error. That is good. Compilation errors are vastly preferable to runtime errors. So, just to wrap this up, even just the naked struct with one value, it's simple, but it actually eliminates a whole class of runtime errors. They vanish. And using private data and a throwing constructor makes it easy to do the right thing and really hard to do the wrong thing. You have to be Machiavellian evil to get there. And you almost always want to use explicit for constructors and conversion operators. Questions on that example? No. Let's go on. A lot of bool. This is a good one. This piece of art is called the Tyrannosaurus Rex. They are for sale, by the way. So we have some function print that takes a string view and some flags. Do I want to truncate the string if it's too long? Do I want to pad it if it's not long enough? Do I want to automatically line feed? Which is, that looks all right. It's readable. But what on earth is that? I mean, if you read this print false, false, true, and you don't see the prototype, that makes absolutely no sense at all. You have no idea what false, false, true means. A technique used primarily in languages that are runtime typed is that instead of using the false, false, true directly, you create local variables that are like no truncate equals false, and then you call it with no truncate, etc. That works. But they are still all bools, and you can rearrange them in very confusing ways. So now the code is easy to read and still completely wrong. So what can we do? Can we do better? Well, Enum class to the rescue. When I say create now Enum class truncate off on and the Enum class pad off on, Enum class line feed off on. These are unique types that are not interchangeable in any way. And unlike the C-style enums, these really are unique types. The C-style enum is a glorified int. And you always name them with the full scope. So this code now is, in my opinion, very easy to read. You understand directly what this means without problems. And since each of these values have different types, it means that if you make a mistake, you happen to call it with pad off and then truncate off, you will get a compilation error. Again, a compilation error is vastly preferable to a debugging session. So Enum class is cool. Use that. Although, yeah, this is... I'm not happy about this. It sort of comes natural that you want to have the name of the parameter and the type the same. And you can actually have them exactly the same, which is somewhat confusing. And it also then hides the name of the type if you want to refer to that in the function. So I don't know what's a good way to do this. I just lazily added an underscore at the end because it's still readable. So to begin with, you almost never want bool parameters. And you especially don't want several bool parameters to the same function. And Enum class adds the good kind of verbosity that enhances readability. It makes it much easier to understand what the intent of the code is. A function call with false, false, true, that maybe it felt good when you wrote it, but not half a year later. Absolutely not. Let's go to another one. My memory is failing me. I think that's the were rabbit. So same code as before, mostly. I shortened the names a bit. The difference is that we have a default on the end because it makes kind of sense that a print function, you get a line feed by default. That makes sense. This is actually taken from a real-world problem some colleagues of mine had, and they wasted 3-4 days on it. Just so you know how cheap this problem is. So the reason for this is a different one. This code works. I mean, it's terrible due to all the reasons I showed just previously, but it works. It's fine-ish. But this is problematic in the face of change in the code. Code evolves. Who has ever written a function that you wrote once and it stayed the same forever? It's never changed again. Software isn't like that. You change it. So in this case, I want to add a new field. I want to actually add a field size as an argument. That makes sense for a print function, especially when I have trunc and pad also. So add this. And this still compiles. And you're not even getting a warning for it. Because bool is an unsigned integer type with a value space that perfectly fits within the value space of size t. So it's a safe conversion. Have fun. So what can we do? Well, actually exactly the same as before. We use the types, the Enum class, to get unique types. Because when you then add this field, you cannot forget to update some call site, because you will not get it to compile. You will get an error that says, I have no idea how to convert truncate off to a size t. So Enum class is really good. By the way, feel free to interrupt at any point if you wonder about something or want to point something out. So, yeah, Enum class is good. Use Enum class. So, default parameters are just extremely dangerous over time when the software changes, if the parameter types are interchangeable. If they're not interchangeable, they can be confusing, but they're not dangerous. And unique and non-convertible types catch this problem. The compiler will tell you if you forget to update someplace. Yes?
Should we wrap the size argument in a struct as well?
Should we wrap the size argument in a struct itself? Maybe. It is probably a good idea. Actually, I prefer to do that, to have a size that is a field width type, because you have several other uses of size t in your code base, and they probably mean completely different things. But a field width type is its own type, it's its own thing. So thank you for that. Yes?
One thing that bothers me a little bit is that now every time that you want to use those new things in the standard library, for instance, you'll need to static cast all the time in order to provide the data to some external function that you don't have the access to really write.
Yeah, so the observation was that whenever you want to use these types somewhere else that doesn't know about these types, then you need to cast to a bool or an int or whatever, and that is cumbersome. And yes, it is. I agree. I still prefer, my personal preference, I prefer to do that over having runtime errors. But I agree that it's not convenient. Okay, couple of parameters. This one I know. This is how the West was won. This is one that I have experienced many times, and I realize that I'm going way too fast. I should have a cup of tea. Any of you do networking? All right. So you know about this. This is how the POSIX APIs for networking look. So almost everything is APIs that use a memory area, and the way you identify the memory area is a pointer to the start and how many bytes the size of the memory area is. So here's a fun thing. So I have a function receive packet that takes a pointer to the start of a buffer and the buffer length. And then I parse a header from this memory area. And then I copy the payload after the header. You see the bug? So buffer length is the length of the entire buffer, and now we moved the start by header length, and then we get the whole rest of the buffer length after that, which means that we have a buffer overflow. That's how you get a CVE number. Well, there are other means also, but it's one of the techniques. So, the problem here is that we have two parameters here, buffer and buffer length, that actually refer to one thing. We want a type that says, here is a contiguous memory area that you can use. That is its purpose. So let's see if we can represent that in one type. Hold that thought. I'm coming back to you. I'm not going to repeat it because I will get there. So let's do this, a buffer view. Then now we have the beginning of the memory area and the length of it as const data. Const is good because it's immutable. It means that within the scope of the function, they are true. They mean the same thing. They will not mutate and become something else. That is good. And then we have functions that create sub-views. In this case, to get a prefix or the suffix after a prefix. And here we have a design choice to do now. What should we do if the length doesn't make sense, if it's too long? We could choose to abort, we could choose to throw an exception, or in my case, I truncate. Your choice. You can choose to overflow and have the same problem as before, but that is maybe not a good idea. So by doing this, we can now transmogrify this program a little bit so that receive packet uses a buffer view. We get the header instead of just the header length. And we call copy payload with packet suffix after header.length. In my opinion, this code tells quite clearly what we want to do. It is still possible to make mistakes, of course. It's always possible to make mistakes. But since the code tells you what you want to do, it's easier to see if it actually does what it should do, instead of if you're just seeing the low-level arithmetics that achieves what you hopefully want it to do. But immutable members can be problematic. It means that we, for example, cannot easily use these in some standard containers, especially in combination with some functions. Say that you have a vector and you want to remove an element in the middle, then the rest will be copied, but they can't be copied because they are immutable. Or copy assigned because they are immutable. So, okay, what can we do? Well, we can create a buffer view class that we have the same. We have the start and length as private members. They are mutable, so now we can copy assign. But they are private, so they can't easily be mutated by mistake. And in this case, I choose to get access functions begin and end because they play nicely with the range 4, which can be cool. And here is a really important thing if you're doing this. Resist the temptation to add too much. it is so easy when writing classes like this to think, yeah, and that will be useful, and someone will surely want this thing, and that would be really cool to add. So, and then you have a very bloated class with hundreds of member functions to string, and that is a maintenance burden. Every time you need to do something, you need to think about all these functions that absolutely no one uses. So add what you need here and now, nothing else. And if you need to add more, then add it. It's not like the first try was cast in stone and can never be changed again. Add new functions. It's software. It's soft. So, coupled parameters, yes. So when you have several parameters that together describe one thing, try to model that one thing as one type. And studspan was mentioned. Studspan is a way to model a contiguous memory area. But I say this as someone who has actually used studspan a lot directly in internal functions that use exactly just packet parsing. Don't. By all means, implement this buffer view in terms of span. Please do. That makes perfect sense. But span allows a lot of things that you probably don't want in your buffer view. So, because it is very rich in what you can do. So don't use that naked in your internal APIs, but implement your types in terms of it. Is my opinion. I've forgotten the name of that one. Too many defaults. Yes, this is so much fun. Somewhat contrived example, I'm afraid. We have some kind of server socket, which we say that, yeah, which port should you bind to? Is it TCP or is it UDP? Which address should it bind to? It makes sense to default to 0.0.0.0. That is the all interface addresses that the machine has. Multicast, probably not, but maybe sometimes. So it makes sense to have this as an optional that defaults to null opt. So you can set it when you actually want it. And do I want the I/O to be non-blocking or blocking? Non-blocking is probably a good default. But what if I want to create an instance of this where I just want non-blocking to be false and the rest to be defaulted? That is not fun. The language doesn't work like that. You always have to add the parameters in the order they are written. We don't have named parameters in C++. But what you can do is we can create a configure struct that has all these members. So have a port, and we use the member initializers to get what the defaults are. And then we can call them with if you're in C++ 20 or later, you have these named initializers. So you just say, yeah, I want to create a socket on port 1666 on localhost, and I want it to be blocking I/O. This is quite readable. If you're not on C++ 20, I'm afraid that you will have to first default construct something and then individually add the deviations from the defaults. It's not pretty, but it's not the end of the world either. I've heard some arguments that this is so expensive, but for crying out loud, we're opening a socket. It doesn't matter. Okay, but, if you omit to add something to port doesn't have a default. You should really set the port. And omitting the port is not an error. Recent GCCs give a warning for that if you compile with WExtra. I have completely failed to get Clang and MSVC to warn for this. Great fun. So what can we do? Use a different type. Yes. What type should that be? Some type that must be initialized. Yes, you have read my slides. Here is the most advanced piece of code that I'm going to show today. It is advanced because it is a template. So must init is just a T that must be initialized. And the way it must be initialized is that there is no default constructor. Who here was at Chris van Ren's talk this morning? Chris was, yes. A few hands. He went into quite some detail about this and other rules about constructors. Watch it when it comes out on YouTube. The thing that happens here is that since we have a constructor that takes an argument, it means that the compiler will not create a default constructor for you. Which means that if you try to default construct, you will get a compilation error. And conversion operators to get the underlying value. And here I'm violating the advice I gave just a few slides ago, because I said you almost always want them to be explicit, and here I don't. If you would give me this code on a code review and had them explicit, I would definitely not strike down on that at all. That makes perfect sense. I decided not to, just to show that almost always doesn't mean absolutely always. In this case, I'm here to use this for port, and for all intents and purposes, I just want a uint16t. I just want to ensure that it's not default initialized. That is the only thing. So it doesn't really matter that the conversions are implicit. So we change our struct to config struct to say a must init uint16t, and now the code will compile to fail. I will fail to compile if you forget to initialize it. So yeah, problem solved, easy. So creating structs with parameters is helpful when you have many of them. Victor.
If zooming back a bit to the original example, how do you feel about make functions for utility to create, let's say, a non-blocking socket with a specialized function?
How do I feel about utility functions for creating things like sockets? Yeah, sure. I don't mind. I crafted this example just to show how the structs with defaults makes sense sometimes. Yes?
Some paradigms add methods to this config function that return mutated config, like set TCP set port, you can like chain them.
Mm-hmm.
Each one of them returning an ordered one.
The builder pattern.
Yeah. Okay, so the question was about the builder pattern where you create a config and then you can set something and it returns a new config struct that you can mutate again and mutate again and mutate again and mutate again. Yeah, you can do that. I think that it's more convenient to use the designated initializer and just write the values. One confusing thing about this pattern that you mentioned is that you can initialize the same value again and again and again and again and again unless you do some really horrendous TMP shenanigans, which you probably shouldn't do. But yeah, it's a perfect valid pattern. Yes?
This overlaps quite a lot, I think, with your first example with the enums, really.
Yes.
So my question would be like, wouldn't you just always use the config struct because this covers your enum case and is extendable to...
So the observation is that this config struct functionally overlaps quite a lot with the function with a number of bool flags. And I agree. And So I guess your question was, should you prefer to use the config struct instead? Maybe. I'm not sure. If you have very many of them, you definitely should do a config struct if they all have defaults. If they don't have defaults, I'm not so sure. And if there are 2 or 3, I'm not sure. Yeah.
Do you have a naming advice for those things? Like, assume you have 20 methods now, they all have this config. How would you name them?
Oh yes, the naming questions. Yeah, the question was, you know that engineers are terrible, software engineers in particular, when it comes to naming. Yeah, call them type 1, type 2, type 3. No, sorry, I don't have any advice. Naming is hard. So anyway, what I wanted to say that I think that this is a very helpful idiom to use when you have many parameters, and especially when many of them have reasonable defaults and you just want to change the one where you want to deviate from the default. And it's especially useful in C++20 due to these designated initializer syntax that makes the code so much more readable. Wrong key, yeah. So we have, this is also, it's such a contrived example, I'm sorry. We have some kind of controller dispatcher thingy that keeps a number of network sessions, both client and server sessions, alive, and you choose to control their lifetime. And we have like a function here, close server, and another close client. But, oops. Oh. See if I can get this on. Nope. Thank you. Okay, yeah, thank you. Small accidents, not only in software. So we accidentally happened to erase the client session when we intended to close the server session. That is kind of bad. The problem is that we are identifying the client and the server with int. We use type aliases, but a type alias is essentially a comment, really. What it says is, please, in this situation, use this int only as a client ID, and here you only use things that you know as server IDs, but they are ints. And you can do, I don't know, get the median server ID, whatever you use that would be. And they are completely interchangeable. And the compiler doesn't read comments just like you don't. So this does not really help much. They are ints. They're just called something else. Enum class to the rescue again, but this time where we explicitly say what we want the underlying type to be. So we say that a client ID is a unique type represented by an int. And the server ID is a unique type identified by an int, or implemented in terms of an int. And again, these are now unique types. They are not interchangeable. You cannot cross-assign, cross-compare, or anything. But you need C++ 17 or later. It was added in 17. But I think you're all on 17 or later, I hope. So now I get a compilation error for this mistake. It says, I don't know how to close a server ID with the server ID. It doesn't make sense. I don't have any such function. Sorry. Yes?
What would happen if it did make sense? And you would have to convert it into a client ID.
Can you repeat again?
Yeah, what would happen if it were legal that the server ID, you would like to delete the client upon the server ID, not upon the client ID?
What would happen if I would want to erase a client with a server ID? I'm sorry. Why on earth would you want to do that?
It depends how you manage your IDs. But
Yeah. Then you have a completely different type of problem. You want different types that you use in a different way. You would probably want to create them as different types, but convertible. Say that you want a server ID to be convertible to a client ID, but not the other way. Maybe.
I said that
Yeah.
I would expect you to solve it by collecting the client and the ID into one class, and therefore just expose an erase function or whatever, and by that you won't be able to mix between the two if that's what you meant. But since you put them both in the same class, then it feels better to me, because you are not encapsulating the problem of one
Yeah.
client.
Yeah, so the observation is that maybe this is a really poor design and you shouldn't have an aggregation of all clients and servers, because that doesn't make sense. And I actually agree with that. Victor?
What happens for complicated keys like string keys?
We'll get to that. The question was about more complicated keys that are not just integral types. Yeah, so the thing here is, now we have different types. The types themselves have a meaning. We can argue that this is redundant information. You could just say close session on a server ID or close session on a client ID and let the type decide which is which. Because now they are different unique types that are not interchangeable, which means that you can overload on them. You cannot overload on type aliases because they are comment. Whether you want to do this or not is a completely different discussion, but it gives you the choice. Earlier you didn't have the choice. So how does this work when we have this? So you can create your type from client ID here from the underlying type, which is int. You use static cast to get the underlying type, get it back again. If you're on C++23, you get two underlying, which saves you from the embarrassment of adding the wrong type in the static cast. So that is good. And you have built-in equality and ordering for them, so they are useful directly as keys in stud map or stud set. So they are useful for that. But for Victor's question, what if the keys aren't of integer types then? How do we handle that? By working more. We cannot use the string as the underlying type for an enum. C++ doesn't work like that. It insists on them being integral types. But I can create a server ID type that has a string. And I have an explicit constructor, because that is what you should probably have. And a conversion operator, explicit, because that is what you probably should have. And C++20 magic spaceship operator that gives you all the comparisons automatically by just calling the same comparison operators for the members. This saves a lot of work. You, of course, don't need to use spaceship operator. You can write less than, less equal, greater than, greater equal, 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 not equal, but upgrade to 20, please. It saves you a lot of work. So, did that answer your question, Victor?
I have one more.
Okay.
What if you need a hashed container? You also need to hash that new type.
What if you want to hash it? Well, that is not very difficult. You you need to provide your own hash function for your type, and then the hash containers just work with that. So Enum class is great for creating new integer types that are unique types, and C++ spaceship operator saves a huge amount of work. It's magical. So I'm getting to the end here. So using types reduce the risk of calling functions with the wrong values, with the parameters in the wrong order. They reduce the risk that dependent values diverge, like this buffer view that I showed you, where you have a contiguous range of bytes. By expressing them as one type instead of several, you reduce the risk. Not eliminate the risk, but you reduce the risk of making mistakes. Types makes it easier to manage defaults. We have seen a few techniques for handling them. And using types can prevent accidentally uninitialized data. Or in the case of the struct, it's not actually uninitialized, it's 0, but 0 does maybe not make sense always as a default. Types have been with C++ since before it was first standardized, but they just get more and more convenient to use. And C++ with the designated initializers and the spaceship operator makes life so much easier. And types make your APIs more expressive. Because you're saying, not just saying, this is a number, you're saying what the number means, what its purpose is. And here is an important bit, the last ones here. It's that you rarely know when you start writing your program what your types should be. You discover them as you go. And as your code evolves, you learn more about the problem domain, you learn more about which data is passed where, you discover types, you write these new types, you start using them in your system. Refactor, use more types, discover new types, create them, introduce them in the code. When you do that, something absolutely magical happens, and that is the inverse code rot thing. I used to be a firm believer that you start with a nice idea of what you want your software to do, and then reality hits, and it hits again, and it hits again, and it hits even harder again, and after a time, it's just a mess. But when you reflect over what information is passed, what it means, and you express it as types, then your code starts, after a while, to evolve into expressing its dynamics in terms of the problem domain, instead of as the arithmetic means to achieve the solution to the problem. So use types. It makes your code so much better over time. Just this last bit. Don't forget to incorporate those new types in your program. If you see that, yeah, I should totally use a client ID here, and you add it in one place, and everywhere else you have int, you have failed. So introduce these types. Let them percolate through your system as it goes. You add them one by one, here and there, now and then, and the code just becomes cleaner and cleaner. So, some more things to look at. 1 year ago, in this room, Shandor Dargo, who's sitting there, had this presentation about using type-safe, writing type-safe containers. And I think it was an excellent talk. Thank you for that. So you should watch it. He goes through a number of things to think about when you model containers as their own unique types. And if you're curious about learning more about what to think about when create types, Peter Sommelad's presentation from CPPCon 2021 is really good. So this is more, it's more theoretical. It's not really hands-on, but it's very useful. Strongly recommended. And also visit Puzzle Montage and look at the amazing Jigsaw puzzle mashups. They are super cool. There are many more than I showed you. And maybe buy one or two. I have no affiliation with the artist, by the way. That is all I had to say. Thank you very much for your kind attention.